Okay, so regression equation here and getting a sense of what it means and how to use it. We have that the highway miles per gallon for a car equals 4.62 plus 1.109 times whatever the city miles per gallon. And um, yeah, let me just go ahead into the questions here. So the slope is whatever is connected to the variable. It doesn't matter if it's coming first or second in the regression equation. What it means is that it's connected to that independent variable. So this 1.109 is what's connected there. And what that actually means is, if you think about it, every time the city mileage goes up by 1, then it will get multiplied by this 1.109, and the highway miles per gallon will go up by 1.109. So for every additional 1 in the city mileage, you'll get an extra 1.109 in the highway mileage, which makes sense because highway doesn't have as much starting and stopping. So we would expect that number would go up more quickly than the city miles per gallon. Next thing is the intercept. So the intercept is going to be the number that's separated. It's kind of standing off by itself. In this case, it's the 4.62. And in order to figure out if that's meaningful or not, what we would do is put 0 in for the city miles per gallon, because that's when the intercept would really come into play. It would stand on its own when this independent variable, this x variable here, was equal to 0. So when would a car's miles per gallon be equal to 0? Well, it probably wouldn't. My comment here was the only time it would is if the car was completely broken, then it would get 0 miles per gallon in the city. But if that's the case, it would also get 0 miles per gallon on the highway. So in this case, we don't have a meaningful y-intercept. It doesn't tell us much because it's not realistic for the city miles per gallon to be 0. And then finally, using the equation, notice that we could really do it either way. They've given us the city mileage in both cases, so 16 miles here, and then 28 is the next one they give us. So what we would do is plug that 16 in, multiply it by the 1.109, add 4.62, and we get that the highway miles per gallon is 22. So if you have a car with a 16 miles per gallon in the city, should get a predicted 22.364 miles per gallon on the highway. And if we put a 28 here, go through the same calculations, we get 35.672. Now this isn't going to be exact. This is a prediction. When we're using this regression equation, we usually have data on this and we're trying to predict this. But on average, based on the data that we've seen, this is our prediction for what the highway mileage would be. We can also go the opposite. It doesn't ask us that here, but if we want to know what city miles per gallon would a car have to get in order to get a predicted highway miles per gallon of, say, 40, we could plug in a 40 here, subtract the 4.602, divide by 1.109, and we'd get the city miles per gallon that we'd have to have in order to get a predicted highway miles per gallon of 40.